All right, my astronomy project is going to be about Venus's atmosphere and the relative forcing due to the greenhouse effect on it, and the internal energy retention of Venus's atmosphere. All right, to start, we're going to calculate Venus's relative heat balance, but with a albedo, but without an atmosphere retaining energy. To start, we know that the R of the sun is 6.9 e to the fifth, and the temperature is 5.778. Using Stephen's Boltzmann's law, we're gonna calculate the sun's flux at Venus by using a ratio of the sun's radius divided by the radius of the power sphere to get the flux at Venus. Then we're going to balance that out and use the albedo, and 1 minus the albedo to find the absorption of the planet, and solve out to find the temperature of Venus. And that we get is 262 Kelvin. This is without energy retention due to the atmosphere. So we know that that Venus's surface temperature is 733 Kelvin. So we know there has to be some energy retention due to the atmosphere. So to solve that, we're going to use a two-body approximation with the ground here and the atmosphere on a single plane. So we know that the flux of the sun comes in, some is reflected due to albedo, then is absorbed by the planet. And then that is re-emitted, the same amount is re-emitted. And that is either let out to space or retained and pushed back into the system and then re-emitted. So this re-emission will decrease with every iteration. And since we're always getting a flux from the sun, these adding up adding up the infinite series of these as it goes to infinity will equal the total flux density out of Venus at any given point in time. And then from there, we can calculate the temperature using Stephen's Boltzmann law again. So I calculated a energy retention of 98%. So that it's retaining, and then you're adding it as infinite series, and solving infinite series gets you 50 F times F of V. And then solving that, you get 700 Kelvin as the approximate energy retention. With 90%, we were still only getting 450 Kelvin. Earth's approximation, which would be the same exact calculations, you get an approximation of 50%. My sources are the Discovering the Central Universe by N. Cummings, Atmospheric Science and Introductory Service by J. Wallace and P. Hobbs, Wolfram Alpha by Wolfram Research. These are my two figures or pictures. Thanks. That was my presentation on Venus's atmosphere and relative forcing of the greenhouse effect.